Rates and returns, or time value of money. So friends, this is a new chapter that we are going to study today, and it is a very foundational chapter in a sense that in the future, whether you want to value fixed income instruments or equities or any other securities for that matter, time value of money or rates and returns plays a very foundational or fundamental role. So it is very important that we clear the concepts here so that going forward we can apply these concepts and expand on them to do the valuation of any kind of securities that we are asked to do. So friends, let's get started. So friends, let's say you have a deposit in a bank named ABC. Okay friends, and you want to convert that deposit into a fixed deposit for 5 years. Now the rate provided by ABC annually, let's say 7%. Annual rate. Now if somebody asks you the question, at the end of 5 years, what is the return that you are expecting? Let's say your deposit amount is $1,000. So if somebody asks you that at the end of the 5 years, what is the amount that you are expecting to receive, friends? How would you calculate? Obviously, let's say this is t is equal to 0, 1, 2, 3, 4, 5. At t is equal to 0, your deposit amount was 1,000, right? Now the bank is providing 7% returns, right? So your amount at the end of year 1 should become 1,000 multiplied by 1.07. Then at the end of year 2, another compounding happens. So your amount becomes 1,000 multiplied by 1.07 to the power 2. At the end of year 3, another compounding happens. So this amount becomes 1,000 into 1.07 to the power 3. Same happens in year 4. So your amount becomes 1,000 into 1.07 to the power 4. And obviously at the end of the 5th year, your amount ultimately becomes 1.07 to the power 5. So what was 1,000 at t is equal to 0 becomes 1,000 multiplied by 1.07 to the power 5 when the year is 5, right? So if you have to generalize it, friends, whatever is the present value right now at t is equal to 0, at some period, let's say t is equal to capital N, this PV becomes present value multiplied by 1 plus the periodic compounding rate R raised to the power of the number of periods. This expression is what we call the future value, FV. So we can write this as FV is equal to PV multiplied by 1 plus R to the power N. This is the core equation for converting present value into future value, friends, when we know the number of periods and the rate of compounding at each period, friends. Now we'll make it a little more complicated. This is a simple form where we had just an initial investment, no interim payments were there, and we knew exactly the number of periods and the compounding rate for each period, right? So friends, we have learned so far that FV, future value, is equal to present value multiplied by 1 plus the compounding rate raised to the power the number of periods for which the compounding will happen, right? Now let's say we have $1 million, right? And we want to invest it for 10 years at a rate of 8%. So the question is, what is going to be the future value of this kind of an investment? We can find it out, friends. FV is equal to 1 million multiplied by 1.08 raised to the power 10. Let's calculate it, friends. So friends, this is coming to be 2158,924.99. 2158,924.99, or approximately $2.15 million, right? So this is the way we calculate the future value when our present value, compounding rate and number of periods are given. Now friends, we'll complicate this thing a little further. This is the most basic foundational equation for calculating present values and future values. We are going to complicate it just a little bit, notch by notch. Okay. So now let's say you have a bank ABC providing you FD at 10% compounded quarterly, 10% annual rate. This is the annual rate. Compounded quarterly, they are saying. Okay. And you have, let's say, $500 with you. Okay. Now the tenure of the investment, let's say, is 3 years. Okay. Now the question is, what is going to be the future value of this investment? Same as that, right? Now how do you find this out? So here the key thing is 10% annual rate compounded quarterly. What does this mean? This basically means that the compounding will happen 4 times every year. Right, friends? So how do you calculate this? To calculate this, what you do is you divide 10% by 4. You add 1 to it and you raise this entire value by the number of years multiplied by the number of periods the compounding is going to happen. So this is equal to 1.025 raised to the power of 12. So the future value becomes FV is equal to 500 multiplied by 1 plus 0.10, which is nothing but 10%, divided by 4. This expression, this second expression, raised to the power of 4 into 3, or 500 multiplied by 1.025 raised to the power of 12. The value is equal to $672.44. This is the final answer, friends. Now if you want to generalize this formula, it becomes there are n periods and the rate R is compounded m times, small m times every period. This m here is called periodicity, right? So in this kind of a scenario, m is the periodicity, n is the number of periods, r is the compounding rate. FV here will be calculated as FV is equal to PV multiplied by 1 plus R by the periodicity, this expression, raised to the power of n into m. Let's do another example, friends. We will understand it better. Let's say there is a bank XYZ which is providing FD for 5 years at the rate of 8% compounded monthly, 8% annual rate compounded monthly, right? If you invest $1,000 here, that is $1,000 is your present value or present amount, then what is your future value? This is the question, right? This is the question. Now how do we solve it? FV is equal to present value or $1,000 multiplied by 1 plus the annual rate, which is 0.08 or 8%, divided by the periodicity. Periodicity here is monthly, which means we divide by 12. This expression raised to the power of 5 into 12. 5 is the number of years or number of periods multiplied by the periodicity. So this value will become, you can easily calculate it, friends, 1,489.8. So your FD after 5 years, its value will become $1,489.8 approximately. So this is the way you do the calculations. Now we have done quarterly, we have done monthly. We can make it more refined, right? We can make it daily. We can also make it continuously. What will happen if we make it continuously? Let's see that. The question is, your bank ABC gives you a 3-year FD at 10% compounded continuously. If you invest $2,000 in this kind of an FD, 3-year FD, compounded continuously at 10%, what is going to be your future value of investment, right? So the calculation here is going to be done through exponential equation. So in case of continuous compounding, the expression of FV, future value, is given by PV multiplied by E, exponential, raised to the power of R into the number of periods. So FV here becomes equal to 2000 multiplied by E to the power 0.1 into 3, right? Let's see what the value is. So this is equal to 2000 multiplied by 1.3498. This is equal to 2699.7. Right, friends? So in case of periodicity, what can happen? We can compound annually. We can compound half yearly. We can compound quarterly. We can compound monthly. We can compound daily. We can compound continuously. And one very, very key insight I want to mention here is, if the compounding is continuous, then the end value or the future value will be greater than the daily compounding value for the same initial investment. And if the compounding is daily, it will be greater than the monthly compounding future value for the same initial investment. If the compounding is monthly, then the future value will be greater than the quarterly compounded future value. And same it goes. Quarterly will be greater than half yearly. Half yearly will be greater than annually. If you want to verify, we can verify with this example itself. So let's do it, friends. Case 1. Continuously compounded at 10%. The value comes to be $2699.7, right? Initial investment was $2,000. Case 2. Let's do a daily compounding. Daily compounding at 10% only. Now, let us consider that there are no holidays in the bank. Every day is working, so compounding is happening every day. So what will be the calculation, friends? Future value will be equal to 2000 multiplied by 1 plus 10%. 10% or 0.10 divided by 365 to the power of number of periods, which is 3, into periodicity, which is 365. Let's calculate the value here, friends. So this is equal to 2000 multiplied by 1.3498. This is equal to 2699.6. So 2699.6 is obviously less than 2699.7, right, friends? Very close, but still less. Now let's see what happens when you do a monthly compounding. So case 3, monthly compounding at 10%. Here the future value will be given by FV is equal to 2000 multiplied by 1 plus 0.10, which is 10%, divided by the periodicity, which is 12, to the power of 3 into 12, which is 36, you can write, right? So let us again calculate this. This is coming to be 2000 multiplied by 1.3481. This is equal to 2696.36. Now 2696.36 is obviously less than 2699.6. Now we'll do case 4, which is quarterly compounding. Quarterly compounding at 10%. Here again the future value, let us write this. FV is equal to 2000 multiplied by 1 plus 0.10 by quarterly periodicity, so which is 4, and raised to the power 3 into 4, which is 12. This is equal to, again let us calculate the value, 1.025 to the power 12. This is 2000 into 1.3448, and the value will be equal to 2689.7. 2689.7 is less than 2696.36, friends. Now we'll go into case 5, which is half yearly compounding. Half yearly compounding at 10%. Here again the FV will be equal to 2000 multiplied by 1 plus 0.10 by 2. Because periodicity is half yearly, we divide by 2, and raised to the power 3 into 2, which is 6. So this is equal to 1.05 to the power 6. 2000 into 1.34. This is equal to 2680.2 approximately. 2680.2 approximately. So 2680 is obviously less than 2689, friends. So we are seeing as the periodicity, the periodicity is decreasing, the future value is also going down. So if the periodicity is continuous, the value is highest. If it is daily, it comes down a little bit. If it is monthly, it comes down further. If it is quarterly, it even comes down further. Then half yearly, again, little more reduction. Now let's see what happens if we do just pure annual compounding, no periodicity. So case 6, annual compounding at 10%. Here the future value is equal to 2000 multiplied by 1.10 raised to the power of 3. Because periodicity here is basically 1. So 0.10 by 1 is 0.10. So we write 1.10, and 3 into 1 is 1. And 3 into 1 is 3. So we keep it 3 here. So what is the value here, friends? 1.10 raised to the power of 3 is 1.331. So this is 2000 into 1.331. Here the value is 2662. 2662. This is the final answer, friends, for annual compounding. And you can see here clearly 2662 is less than 2680. So as the periodicity is going down, the value or the future value is going down. So this is one insight I wanted to share with you from this example. Now friends, we want to reverse the question a little bit. Okay friends. So here we were always calculating the future values, right? Now our question is, let's say there is a bank ABC which provides FD for 5 years at the rate of 12% annually. At the end of 5 years, you want the future value of your investment to be $1,000. At the end of the 5 years, you want your future value of investment to be $1,000. So the question is, how much should you invest now, or what is the present value you should invest in this kind of a scheme? So we already know, friends, the formula for future value. FV is equal to PV multiplied by 1 plus R raised to the power n. Now we want to know what is the PV. So PV is equal to FV divided by 1 plus R to the power n. As simple as that. So this is equal to 1000 divided by 1.12 raised to the power 5. Let's calculate the value, friends. 567.4268 or 4269 approximately. This is the investment you need to make now to get $1,000 at the end of 5 years in this scheme, 5 years at 12% that your bank ABC is providing. Right, friends? So this is how you calculate present value when your future value, compounding rate and compounding periods are given. Now we'll complicate this a little bit more. Let's say bank ABC is providing another FD for 3 years. And this is at 10% annual rate, compounded quarterly, right? What is the current investment for you to get a future return of $5,000? So you want to get $5,000 at the end of 3 years from this scheme. How much should you invest now? What is your present value to be invested? How do you calculate this, friends? This is also very simple. PV is equal to FV divided by 1 plus R divided by periodicity. This entire expression raised to the power of n into periodicity. So here we know all the values. 5,000 divided by 1 plus R is 0.10 or 10% divided by periodicity is quarterly. So divided by 4 raised to the power of number of years 3 into periodicity, which is 4. So this is equal to 5,000 divided by 1.025 raised to the power of 12. We can easily find out the value, friends. 1.025 raised to the power of 12. 5,000 divided by this value. This is equal to 3717.78 approximately. This is equal to 3717.78 approximately. Right, friends? So here we go. What if this compounding was continuous, friends? What if this compounding was continuous? How will we calculate this? Let's look at that. ABC Bank has a fixed deposit investment scheme for 3 years where they give you a return of 8%. And this is annual return compounded continuously. Now you want, at the end of 3 years, you want to have $2,000. How much should you invest now? This is the question, friends. How do we calculate? Very simple, friends. We know that in case of continuous compounding, FV is equal to PV multiplied by exponential raised to the power of the annual return multiplied by the number of periods, right? So PV is naturally FV divided by this expression, exponential raised to the power of R into N. Here we know all these values, right? Future value we want is $2,000. Exponential raised to the power of 0.08 multiplied by 3. So this is, we can easily calculate 0.08 into 3 raised exponentially This value divides 2000. 1573.255 approximately. $1573.255 approximately we have to invest now to get $2,000 under this scheme. 3-year 8% compounded continuously. So this is the way we do the calculation, friends. Now friends, we will learn a couple of new concepts. The first concept that we'll learn is effective annual rate. Now what do we mean by this, friends? Let's say we have a rate 8% compounded annually. Right, friends? And parallelly we have another rate 8% compounded quarterly. So 8% annual rate compounded quarterly. Is there a difference between these two, friends? Is there any difference? Or are both of them 8% only? No, there is a difference, friends. There is a difference. Because let's say we have made an investment in both of them for 5 years. Okay? 5 years. And the investment amount is, let's say, $1,000. Will our future values be same? FV1 and FV2, if we call it, will FV1 and FV2 be same, friends? The answer is no. FV1 will not be equal to FV2. How? Let us look at it through the calculations itself. In case 1, FV1 is equal to 1000 multiplied by 1.08 raised to the power of 5, right? This comes to be 1000 multiplied by 1.4693 is equal to 1469.328. 1469.328 dollars approximately, right? This is for case 1. In case 2, FV2, this is equal to 1000 multiplied by 1.02 to the power of 20. How do we get 0, 2 and 20? It's very simple. Because the periodicity is quarterly, we divide the rate 0.08 by 4 and we get 0.02, which we add to 1, and this becomes 1.02. And this 1.02 we raise it to the power the number of periods multiplied by the periodicity, which is 5 into 4, and we get 20. Right, friends? So 1.02 and 20 are clear for us. Now this becomes 1000 into 1.02 to the power 20. How much it is? 1.02 raised to the power 20. This is equal to 1.4859. 1.4859 approximately. And the value comes to be 1485.947. Now, as we are discussing previously, this value FV2 and FV1 are not the same. In fact, FV2 is more, right? Now, what is creating this difference? What is creating this difference, friends? 1 to the power 5 would have always been equal to 1, which means if there were no interest rates, then your present value would never grow, and the present value will always be equal to future value no matter how long you keep the investment for, right? It can be 1 to the power 100, 1 to the power 200. It always remains 1, right? It does not change. So it is definitely this interest rate, 8% and 2%, which is creating the difference. So we utilize these values 1.08 and 1.02 to get our effective annual rate. 1.08 and 1.02 to get the effective annual rate. Okay. Now the general formula for effective annual rate is EAR is equal to 1 plus the periodic interest rate raised to the power the periodicity minus 1. This is the general formula, friends. Now what is the EAR in case 1? So EAR1 is equal to 1 plus 0.08 divided by 1 raised to the power of 1, because it is annual compounding, periodicity is 1. Periodic interest rate is 0.08 divided by 1 minus 1. This is equal to 1.08 raised to the power 1 minus 1. Simplified, this becomes 0.08 or 8% only. And in case 2, what is the value? Let's check out, friends. EAR2 is equal to 1 plus 0.08 by 4 raised to the power of 4 minus 1. Why 4? Because the compounding is quarterly. So this is equal to, let's calculate, friends, 1.02 to the power 4, 1.02 to the power 4 minus 1. This is equal to 1.082432 minus 1. So the percentage is coming to be 8.2432% approximately. So obviously the effective annual rate in case 2 is higher because the periodicity is higher. So higher the periodicity, the effective annual rate is higher. And that is the main reason why, as the periodicity increased, the future value also increased, because the effective annual rate increases. Now friends, let's do a couple of examples to understand it better. Let's say there is a bank ABC which is providing an investment scheme for 5 years at the rate of 10% compounded quarterly. What is the effective annual rate? So friends, effective annual rate is equal to 1 plus the periodic interest rate raised to the power the periodicity minus 1. This is equal to 1 plus 0.10 or 10% divided by 4 raised to the power 4, because compounding is quarterly, minus 1. So this is equal to 1.025 to the power 4 minus 1 is equal to 10.38% approximately. So you can see, friends, because the periodicity is more than annual, it is quarterly, we are getting an effective annual rate which is more than the annual rate. The annual rate is 10%, but because it is compounded quarterly, we are getting an effective annual rate of 10.38%. So this is going to cause a difference, friends. Another question, let's try out. Let's say ABC provides another investment scheme 2. This is 1, this is 2. This gives a 3-year investment opportunity which is at 12% compounded continuously. What is the effective annual rate in case of a continuous compounding, friends? So first let us understand how we calculate it. Effective annual rate when the compounding is continuous is given by exponential to the power of the interest rate minus 1. This is equal to exponential to the power 0.12 minus 1. Quickly calculate this, friends. This is coming to be 12.7497%. This is the effective annual rate when the compounding is continuous, friends. So this is how we calculate it. Simple, friends. Now friends, we learn something called annuity. What is annuity? So friends, let's say you are looking at investing at an investment scheme for the next 10 years. Right, friends? You are investing for the next 10 years in an investment scheme. The investment scheme offers a return of 10% every year. Okay, and you are looking to invest $1,000 every year in this scheme. So in year 1 you give 1,000, in year 2 you give 1,000, in year 3 you give 1,000, like this it goes on, and even in the last year you give $1,000. Now the question is, at the end of it, what is your future value of all these investments? This is the precious question that we want to answer. And this kind of a scheme is what we call an annuity, friends. Now the investment that you make at year 1, let's call it PV1. This is equal to $1,000. So this year 1 investment, this $1,000 compounds how many times? 1, 2, 3, 4, 5, 6, 7, 8, 9. It compounds 9 times, friends. 9 times, or 10 minus 1 times. So you can write the future value FV1 is equal to PV1 or 1000 multiplied by 1 plus 0.10, 10% to the power 10 minus 1 times. Right, friends? Similarly, let's check out what happens to PV2. PV2 is also equal to 1000. PV2, that is the $1,000 invested at year 2. This compounds once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, and 8 times, friends. So you can write FV2 is equal to 1000 1 plus 0.10 to the power 10 minus 2, which is 8. In this way, if you write all these numbers, friends, your last investment, that is at year 10, the $1,000 that you invest, the future value of that is 1000 into 1 plus 0.10 raised to the power 10 minus 10, which is nothing but 1000 only. Right, friends? So the total future value, if you want to find out the total future value, this is equal to sum of all these small intermittent future values. So this is equal to 1000 multiplied by 1.1 to the power 9 plus 1000 multiplied by 1.1 to the power 8 plus last one, which is 1000. This is going to be the way we calculate the future value of a periodic investment scheme or an annuity. Now if you want to generalize it, let's say if there are n periods, 0 to n periods, and you start investing from period 1, at the end of n periods, what is the future value FVN of your periodic investments? This will be given by FV of all these periodic investments is equal to PV 1 plus the rate of compounding raised to the power of n minus 1 plus PV multiplied by 1 plus rate of compounding raised to the power of n minus 2 plus plus PV, right? We are assuming all these present values or all these periodic investments are same in amount. Let's call it by the name A. So this becomes A into 1 plus R n minus 1 plus A into 1 plus R n minus 2 plus plus A. Now if you take the A common, there is a mathematical way to represent this entire thing. FV of an annuity of n periods is given by A into 1 plus R to the power n minus 1 divided by R. This is the way to calculate an annuity, friends. Simply these, if you take the A common, this becomes a geometric progression, and the formula for geometric progression is being shown here in this expression. It is nothing else. So this is our formula that we can use for calculating the annuities, right? This is an ordinary annuity, by the way, friends. Ordinary annuity means the first investment is happening in period 1, right friends? If the investment had started immediately, that is from t is equal to 0 or period 0, then it will be called an annuity due. We'll get into the expression in some time, but first let us do an example of an ordinary annuity. So the question is, the periodic investment that you are willing to make is $500. $500. And you want to do it for next 20 years, starting from year 1. So this is an ordinary annuity. Now at the end of 20 years, what is the future value of this investment if your rate of return annually is 8%? The question is, what is the future value of your investments if your rate of return is 8%, right? How do we calculate it, friends? Obviously, FV is equal to periodic amount multiplied by 1 plus compounding rate raised to the power of number of periods, this whole expression minus 1 divided by the compounding rate. Here we replace it with the values 500 multiplied by 1.08 to the power 20 minus 1 divided by 0.08. This is equal to 500 multiplied by, let's calculate it friends, 1.08 to the power 20 minus 1 divided by 0.08. This is equal to 45.761964 approximately. So this is coming to be 22880.98215. This is the future value that is coming for this kind of an investment for 20 years at 8%, right? Now friends, let us calculate for annuity due what is the numbers. So for an ordinary annuity, friends, the formula goes like this. FV is equal to A multiplied by 1 plus R to the power N minus 1 divided by R. This is when the first investment happens at time period 1, right? What if the investment starts from time period 0? The same amounts, A, every period, but starting from 0, right? Now in this case, friends, each of these investments compounds for 1 period extra. So if the compounding rate is R, the annuity due expression becomes A multiplied by this whole expression multiplied by 1 plus R. This is all you need to do. This is the formula for future value of an annuity due. Nothing else you need to do, friends. So let us do an example. You're trying to create an annuity due for 30 years at the rate of 12% per year. Every period you'll be investing $1,000, let's say. What is the future value that you are looking at? Future value of the annuity due. What is it? So it's easy to calculate it, right friends? FV of an annuity due is given by periodic amount multiplied by 1 plus R raised to the power the number of periods minus 1 divided by the compounding rate multiplied by 1 plus the compounding rate. This is equal to 1000 multiplied by, let's calculate it friends, 1.12 to the power 30 minus 1. This whole expression divided by 0.12. This is 241.33 approximately multiplied by 1.12. So this is equal to 270292.6. dollars. So this is the answer that we are looking for in case of an annuity due. Annuity due, friends, is something where the periodic payment starts immediately, that is t is equal to 0. And a normal annuity is where the periodic payment starts from t is equal to 1. This is the only difference.